Let's talk about molecular structure and geometry. A good starting point to talk about it would be the Lewis dot structure, but I think you can tell that Lewis dot structures are going to be limited. Here I've drawn a couple, and we always draw them in the plane of the piece of paper or on the plane of the screen. Molecules, of course, have all three dimensions to work with. So rather than being stuck square planar, a molecule can use a third dimension. And the third dimension is important because what the motivating factor for molecular structure and geometry is to get the pairs of electrons that are making the bonds in the lone pairs as far away from each other in space as possible. So you want to use all three dimensions to do that. One thing the Lewis dot structure can do, though, is tell you what you have to separate in space. Because the Lewis dot structure does give you the overall connectivity, who's connected to what in the molecule. For instance, this carbon is connected to 1, 2, 3 hydrogens and another carbon. This oxygen has to accommodate 1, 2 lone pairs, this carbon atom and that hydrogen. So we'll define the steric number as the number of things that each atom has to accommodate. Lone pairs plus bonded atoms. We'll count up lone pairs, 1, 2, and bonded atoms, 1, 2, to come up with a steric number of 4 for this oxygen. When things have steric number of 4, we'll see they arrange themselves not in a square planar configuration, but in a tetrahedral configuration. That is, I'll have one stick here in this plane of the board, and these two going back away from you, and this one coming out at you. So using all three dimensions to separate those 4 things as far away from each other in space as possible. That's the basis for determining molecular structure and geometry.